are now being connected to your conference.
Hello?
Hello.
Hi, how's it going, Jeff?
It's going all right. How's it going with you?
Not so good. I'm trying to.
Uh-oh.
Yeah, I just keep getting I just keep getting the wrong answer, and I'm not too sure why. Let me go ahead and share the question with you here so we can both work on it.
Okay.
So hopefully you have you see what I see.
Yep.
Awesome.
Surface area of a snowball.
Right. So I guess I could go through it once, but it's obviously wrong. But maybe you could show me where I went wrong, sort of.
Sure. Let's see.
Okay.
Okay. So I guess you have the surface area formula handy?
Yes. Yes, I do. Yeah. Surface.
Okay, that's good.
Surface area of a sphere, correct?
Mm-hmm.
Okay. So that would be, let me just go ahead and write that down here.
I used to know that, but I'm drawing a blank on that tonight.
4 pi r squared. So it looks
Oh,
like.
it's that easy.
Yeah, apparently it's what it's what it is. So let me just go ahead and go through what I thought for this problem here. So, you know, on first glance, it's definitely related rates. And so it's saying that the surface area of a snowball decreases at a rate of 6 feet squared per hour. So I suppose I don't really want to write dd over dt to symbolize the. So it's asking for how fast is the diameter changing. So that's why I'm saying I don't want to write dd over dt. So let me just go ahead and have m symbolize the diameter.
Sure, that's probably a good idea. Yeah, DD is not good notation.
Absolutely. So I guess so if I could just make like a column here, sort of what we're given. What we're sort of given here is that the dm over dt, where m is diameter, dm over dt is essentially equal to what they say is 6 feet squared per hour. And I essentially want to somehow relate the diameter, or actually let me just go ahead and keep noting down what I have. If the radius is 2 feet, so it seems like okay, so it's asking me what dm over dt is, but evaluated at r equals 2 feet, right?
Yep.
And I suppose I could just go off to the side here, or actually I'll just write it here. I'll say that m is equal to 4 since the diameter is in fact 2. And so now I don't really have to look for it, but I'm looking for an equation that will somehow relate my diameter with some of the other components that I have, which would be this formula here. So I have a equals 4 pi r squared, and if I take the derivative of both sides, let me just write that down real quick. Pi is in fact a constant, so I have dA over dt on this side equated to 4 pi multiplied by 2r multiplied by dr over dt, and dA over dt. So really, what I really have is dA over dt equal to 8 pi r times dr over dt, and of course I want dr over dt. So dA over dt, I'm given as being 6, and I have 8 pi here, and if I plug in r at that instantaneous moment, which would be 2 feet, and then I have dr over dt, and then finally I could have dr over dt. I could have dr over dt equate to 6 over 16 pi as a final answer.
Yes. So that's all correct. Now they wanted d.
Oh,
Yeah.
it seems like they
Right.
wanted dm over dt, right?
Yeah.
Oh, and I think I solved for dr over dt. Wow.
Yep. So strangely, I thought I did the dm dt and I got the same answers. I must have made a mistake. Let's see. I mean, it would work the same. Oh, of course I did. I went backwards. No, that's R. So R is just D over 2. So I think you could.
Should I just put
change
m,
the R.
r squared to m, maybe?
Yeah, m over 2, right? The R is m over 2.
No, just m squared, maybe. No, just m, because r squared is just the diameter, right? So I could just do 4 pi m.
Or no, 2r is the diameter.
No, I'm talking about the original. Suppose I have this formula here, which I do, 4 pi r squared. Can I just put an m instead of r squared?
No, right? Because
that would make a lot of sense, though, right?
2r is equal to m, and so if I have an r squared in there, so I'd have r is m over 2. And if I squared both sides, I would have m squared over 4 would be what would go in there, right?
Well, Jeff, the thing is, I thought maybe that since m is our diameter and r squared is just the radius times 2, then m can sort of.
R squared is the radius times the radius, not 2 times the radius.
Right, of course. I think that's an error on my part. So you're saying we can't put it for r squared. Where instead do you want to put it? In 2r?
Oh, no, we would put it in for r squared. We just got to put it in the right way, right? So we know 2 times r is equal to m.
Right.
And we have an r there, so we can solve for r. R is m over 2. And so we can just plug in m over 2 for r. And so then you could write that area formula as A equals 4 pi m over 2 squared. So that's basically just going to be pi m squared, I guess, because I'll have a 4 and it'll cancel. I'll have a 4 and a 4 down here. So I guess it turns out to be just pi m squared. And then do exactly what you did, and then we should get the answer.
So let me just sort of backtrack and see if we're on the same page. I thought that you could substitute m, the diameter, into the original formula. But of course, r squared does not represent 2 times the radius. It's in fact the radius times itself. So we moved on to saying that 2r is equal to m. So just before we proceed here, would it work if I were to put m here, perhaps?
And where?
Right.
Oh.
Yeah, right there.
Yeah, except we still have dr dt over here.
Okay.
Let's see. That an M right there, but I still would be doing dr dt, so we'd have to figure out. So I think the answer down here is probably dr dt. R is 2r is equal to m. So if I took the derivative, I would have 2 dr dt equals dm dt. So yeah, I think I would have to.
Yeah, let's
So I'm
just
thinking
forget
the
about that
question.
possibility. Yeah, we can sort
Okay,
of,
let me work this out.
sure.
Okay, so it'd be pi m squared. Okay, so it's going to be 2 pi m dm dt. And we're putting in r is equal to 2, so m would be 4. Yeah, so I'd have 8 pi dm dt is equal to 6. So dm dt is 6 over 8 pi, so it's 1/2 of what we have there,
8 pi.
which makes sense. Like,
So, okay, so if I were to sort of forego going down the route of simply substituting m into 2r, our main goal is to somehow eradicate the r from our original formula. If
yeah,
I'm
I
not
think that's
wrong.
the easiest thing to do. Yep.
Okay. All right. So in doing so, we said that 2r is equal to m. And of course, we can then solve for r and express r as m over 2, and then substitute that back into the original formula and get m over 2 squared, then solve for that and cancel out the 4's. That means the surface area is equal to pi m squared. But I just have one question before we continue taking the derivative of a equals pi m squared. And that question is, it's asking us how fast is the diameter changing when the radius is 2 feet. So where would you plug in r equals 2 in the formula that you want to take the derivative of?
Well, when the radius is 2, the diameter would be 4.
Okay. Wow. All right. Yeah.
I'm assuming that's what you would do.
Okay. That actually sounds. I just thought that was a really hard question for you to answer, but but it seems like wasn't that difficult. I didn't think that question had an answer, Jeff.
Oh.
Thought we had to do something else. So dA over dt, we'll take m here, multiply by 2 here, m, then dm over dt. And seems like since we've taken the derivative of both sides, we can say that dA over dt, surface area, is equal to pi times 2 times m, which we said was 4, times dm over dt. And then, of course, we have, well, let's just go ahead and start plugging in things. So dA over dt, we said, was, so it actually gives us dA over dt. It says that
Yep.
It's 6, and it's equated to pi times 8 times dm over dt. So that would actually be something we want to solve for. And we will essentially have dm over dt equated to what seems to be 6 pi, or no, 6 over 8 pi rather. And that would sort of be a final here.
Yep, that's the answer. Yep.
Wow. You know, it sucks I couldn't think about that myself. I think the more one exposes themselves to different scenarios and related rates, the more they're equipped to handle future problems.
Yeah, that's definitely true. It's something that takes a lot of practice. And, you know, I've been doing these things for years and years, and I can still screw them up pretty easily. So
Really?
they're
Wow.
just, they're just tricky, always.
Yeah. And what about optimization? That's also traditionally a part of Calculus 1. Is that also somewhat difficult or on par with related rates?
Yeah, the hard part is, in both of them. I think optimization problems are usually slightly easier,
Okay.
because you don't have to do, the related equation thing.
Right.
But the hard part in both of them is often, translating the words into the math. So finding the function that you need to optimize is the hard part in optimization problems.
Right. Interesting.
So those can be tricky. So.
Sure, absolutely. Well, did you get your mouse to slow down a little bit while writing?
I tried that, and it didn't seem to help my writing any. So I just said, oh well, I'll leave it as it is and just
Sure.
struggle.
Sure. Well, hey, no, it's completely clear what you're writing, and I mean,
Yeah, well, that's good.
yeah. So thanks for your time, Jeff. Hopefully we can, get together once again
Sure.
and look at these and maybe sometimes optimization.
Okay. Yeah. All right.
All right.
Have a good night.
You too. Bye, Jeff.
All right. Bye.